Right, now we're on question 7. We've got to prove an identity, so let's start with the left hand side, which is cot theta, sec theta, tan theta, root 1 minus sine squared theta. Well, let's put the cot and the tan together because they're going to cancel out. The square root of 1 minus sine squared is cos theta, and sec is 1 over cos theta. So this is 1, so that's the right hand side, and then proof complete. In part B, the left hand side is 1 minus 2 sine squared theta. The right hand side is 1 minus tan squared theta over 1 plus tan squared theta. Well, 1 plus tan squared is sec squared, so that's 1 minus tan squared theta over sec squared, and 1 over sec squared is cos squared. So this is cos squared theta, and cos squared times tan squared, well, tan is sine over cos, so cos times sine over cos is just that. And cos squared minus sine squared theta is cos 2 theta, and cos 2 theta is 1 minus 2 sine squared theta. That's maybe not the best way of doing it. I could have simply said that cos squared is 1 minus sine squared, so 1 minus sine squared minus another sine squared is minus 2 sine squared. Either is okay, so that's equal to the left hand side, and the proof is now complete. In part C, again I think it's worth starting with the right hand side. 2 sine A plus B, that's 2 sine A cos B plus cos A sine B. And then sine 2B is 2 sine B cos B. So the 2's cancelled out, so it's sine A cos B over sine B cos B, and then it's cos A sine B over sine B cos B. So cos B divided by cos B is 1, sine B divided by sine B is 1, and then we've got sine A over sine B. That's good. Oh, I'm in red. Oh well. Sine A over sine B, and then it's cos A over cos B, and that equals left hand side, so proof complete. Okay, in 8 part A we have to differentiate 5 over x squared plus 1. So that's the same as differentiating 5 times x squared plus 1 to the minus 1. So the 5 just gets carried forward, and then if we differentiate x squared plus 1 to the minus 1, it's minus 1 x squared plus 1 to the minus 2. Then differentiate the bracket, because that's a chain rule, that's 2x. So 5 times 2x is 10x, that's a minus sign, and it's x squared plus 1 all squared. In part B, y equals cos squared 4x, so dy by dx is 2 times the bracket to the power 1. Then differentiate the bracket, differentiate cos, it goes to minus sine, then differentiate the 4x and we get 4. So altogether it's minus 8 cos 4x sine 4x. In part C we've got y equals x squared times 2x plus 1 to the half. This is a product, so to differentiate, let's differentiate the first one and leave the second one alone, and then let's leave the first one alone and differentiate the second one. So what have I done there? I've left x squared alone, there it is. The fact that power comes down, The power reduces by 1. What I haven't done yet is differentiate the bracket. If I differentiate 2x, it's 2. We've got a half, we've got 2, half of 2 is 1. So altogether that's 2x plus 1 to the power half, plus x squared over 2x plus 1 to the power half. This question doesn't ask you to simplify it. You could simplify, but that answer there will give you full marks. In part D, we've got to differentiate x squared tan 5x. That's a product, so differentiate x squared and leave tan 5x alone, and then leave x squared alone and differentiate tan 5x. Tan goes to sec squared, but then I've got to differentiate 5x, which is 5. So now let's just tidy that up. So it's 2x tan 5x, and then it's 5x squared sec squared 5x. Now let's do part E. I've got y equals 2x plus 1 over x plus 1 cubed. So dy by dx, this is a quotient. So differentiate the top one first, 2. Leave the bottom one alone. Minus, differentiate the bottom one second, it's 3 times that bracket to the power 2. Differentiate the contents of the bracket, that's just 1. And then we haven't left that alone yet, so we've got to write in 2x plus 1. And it's all over the bottom one squared. 3 plus 3 is 6, so that makes it x plus 1 to the power 6. We need to simplify, so let's take our x plus 1 squared as a factor at the top. So that's x plus 1 squared, that's a plus sign. So we're left with 2 lots of x plus 1 minus 3 lots of 2x plus 1. And then it's all over x plus 1 to the power 6. That's a 1, doesn't look like it, that's a 1. So we've got 2x plus 1 squared there, 2 there, 6 there, so they will cancel to leave us 4 at the bottom. So that goes, and it makes that 4. 4. The world's worst 4, but anyway, that's a 4. So that leaves us in the bracket 2 lots of x plus 1 minus 3 lots of 2x plus 1. Notice that there's a minus sign there. Minus 3 times plus 1 is minus 3. So then it's all over x plus 1 to the power 4. See if I can do about 4 this time. It's not bad. 2x minus 6x is minus 4x. 2 minus 3 is minus 1. And then it's x plus 1 to the power 4. So that's what gets you the full marks. For question 8f, I've got y equals cot x over x squared. That's a quotient. So differentiate the top one first. Cot goes to minus cosec squared. And then leave the x squared alone. There's a minus sign in the rule. Differentiate the bottom one second, so it's 2x. Leave cot x alone, and then it's all over the bottom one squared. Let's just tidy that up slightly. It's minus x squared cosec squared x minus 2x cot x all over x to the power 4. X is a factor at the top, so it's minus x cosec squared x minus 2 cot x, x fourth at the bottom, so that goes with one of those. So then I've got that part over x cubed. I haven't got room to put this in here, to squeeze this in here, I'd need to turn over. But the answer then is minus x cosec squared x minus cot x over x to the power 3. Now let's have a look at question 9. We've got to simplify 1 over 2x minus 3 minus x minus 1 over 2x squared minus 15x plus 18. That factorises to be 2x minus 3 and x minus 6. So that makes life a lot easier, because now the common denominator is going to be 2x minus 3 over x minus 6. So this bit has been multiplied by x minus 6, so that's times 1 by x minus 6. This bit is already over that denominator, so I've got to take away x minus 1. Notice that mistake there. So that's not a good way of writing it. I need to write it like that because taking away minus is the same as adding. X take away x, that's nothing. Minus 6 take away minus 1 is minus 5. Finally, we need to do a division, a long division. X squared plus 1 into x fourth plus no x cubed plus no x squared plus x plus 1. So, how many times is x squared going to x to the power 4? It goes x squared times. Let's do x squared times that. X squared times x squared, that's x to the power 4. X squared times 1, that's x squared. I'm going to put that in there to line it up properly. So that take away that is 0. Nothing take away x squared, that's minus x squared. And now let's bring down the plus x. And we can bring down the plus 1 as well, just in case it's needed. X squared into x squared, that's minus 1. Minus 1 times that, that's minus x squared minus 1. Remainder, well, no remainder there. X take away nothing, that's x. 1 take away minus 1 is 2. So the answer is x squared minus 1 plus x plus 2 over x squared plus 1. In other words, A is 1, B is minus 1, C is 1, and D is 2.